Hi there, I'm Professor Eckhouse, and I am going to talk today about classes of real numbers. So we're going to learn about rational and irrational numbers and the different kinds of real numbers. All right, so first we'll talk about the things we already know. Natural numbers are the counting numbers. As if you were counting things, you would start with 1. The whole numbers are the natural numbers and 0, so we add 0 to the list. And then the whole numbers include all of the above, plus all the negatives of the same thing, so they're opposites. Okay, so take a look at those lists, make sure you understand what those 3 terms are. Because now we're going to add rational numbers to the list. So a rational number is something that can be written as a fraction. It can be written as p over q, where p and q are both integers. So remember, all fractions then are rational, so you'll need to remember that. Every fraction is a rational number. If you see it in decimal form, so if you took 7/8 and you put it in your calculator, you would get 0.875. So that comes from a fraction, so of course it is rational. But how would you know? Just by looking at the decimal. And you know because it is terminating. Terminating means it ends. All right, so if you took 9/11s, and you put it in your calculator, you would get 0.81818181, in other words, 0.81 repeating. So that is a repeating decimal. Repeating decimals are also rational. Okay, so in fraction form, it just has to be integers, one above the other, numerator and denominator. In decimal form, it needs to be terminating or it needs to be repeating. So what is an irrational number then? It's any number that's not rational. It's not able to be written as p over q. It will continue forever without repeating, like pi. Another special number like that is e. The number e, it's on your calculator. But it's a number we use in all sorts of math. And the square root of an integer that is not a perfect square is almost always irrational. I say almost always because I haven't been able to find one that isn't. So I think they are all irrational. I think once in a while there's one that isn't, but you can just assume if it's not a perfect square, it is irrational in this class. All right, so rational numbers. We're going to write each of these as a ratio of 2 integers to prove that they are rational numbers. Okay, so -5 can be written as -5 over 1. That is the definition of p over q, where each of them is an integer, so that's a rational number. 2.13 is 2 13/100ths, and we can rewrite that as 213/100ths, just converting it to an improper fraction. So that is a rational number. 9.71 is 9 71/100ths, which can be written as 971/100ths. So that is a rational number. -5 4/5 can be written as -29/5. So that is a rational number. And 4 6/7 can also be written as 34/7, a rational number. So notice all of these are an integer over an integer, which means they're a rational number. All right, so some rational numbers in fraction, integer, and decimal form. You might just want to pause the video and just kind of soak that in a little bit and try to decipher what they're trying to tell you here. But they've got it as just a number, as a ratio of integers, and as a decimal number. And I do believe there was one typo. I think they meant to put this negative in front just to be consistent. All right, I'm not going to spend time going over that, so pause the video and watch that. Take a look at it if you would like. All right, so irrational numbers. Irrational numbers are things like pi, 3.141592654, and so on and so on. It never repeats, and it goes on forever and ever. The square root of 5 is not a perfect square, and if you put it in your calculator, it looks like it ends, but it doesn't. It goes on forever and ever. So remember, is a decimal number rational or irrational? If it stops or repeats, like we just set up above, stops or repeats, it is rational. If it does not stop and it does not repeat, it is irrational. All right, so we're going to identify each of these as either rational or irrational. So from what I just told you, pause the video and see if you can figure out which is which. Okay, so this number repeats, 0.6233333, so this one is rational. The next one ends. It does not keep going, so it is also rational. The next one, it doesn't repeat anywhere, and the dot, dot, dot says it goes on forever, so that is irrational. 0.3225 with a line over the 5 means the 5 repeats forever, 5, 5, 5, 5 forever. So that is rational because it repeats. So remember to look at the rules if you get confused. If it stops or repeats, it's rational. The next one is long, 5.330567, but it stops. So it is rational. Pi is irrational, always. It goes on forever without repeating. And the next one I didn't show you here. There wasn't room, so why don't you try these next? Oh, there's 4 more. Try these next 4. All right, so 7 is not a square root. So when you take the square root of it, you will get an irrational number. Square root of 36 equals 6, so that is a rational number. Square root of 3, there's no perfect square, so that is irrational. And the square root of 25 is 5, so that is rational. So perfect squares are rational. If they're not perfect squares, they are irrational. All right, so classifying real numbers. We've been talking about this, but I'm going to put it all together in one picture. Real numbers are numbers that are either rational or irrational. So all of this over here we have talked about. This we just talked about, and all of this makes up the real numbers. Okay, so we've got either irrational or rational numbers. Rational numbers are made up of integers, whole numbers, counting numbers going in. Okay, so counting numbers, remember, are just 1, 2, 3, and so on. Whole numbers are 0, 1, 2, 3, and so on. Integers go into the negative, so -2, -1, and dot, dot, dot. 0, 1, 2, dot, dot, dot. Rational numbers is anything that can be stated as P over Q. And irrational numbers is everything else. And all of these make up real numbers. All right, so now the last thing we're going to do is we're going to determine which categories each number belongs to. And the best way to do these is to do it yourself. So just try these and see if you get them right. So I'm just going to put a check mark in the ones that are correct. And so I'll do number -4 for you. So -4 is not a whole number. We're not doing counting numbers in here because it's a little repetitive, because counting numbers and whole numbers are exactly the same except for the 0. So it is not considered a whole number because it's negative. Whole numbers do not include negatives, right? So these are not negative. They start with 0 and go up. So it is an integer. It is rational because it can be stated as -4 over 1. And it is a real number. All right, so why don't you try the rest? Okay, so 5/8 is not an integer or whole number, but it is rational because it is the ratio of P over Q, and it is real. 6.23 repeating is not whole or an integer, but it is rational, and it is real. 15.7, again, not whole or an integer, but it is rational, and it is real. So all rational numbers are real. All irrational numbers are real. So what do you think? We're going to have a check mark in every real number? Yeah, everyone's going to be real. All right, square root of 11 is not a perfect square, so this one is irrational, and it is real, because remember the irrational numbers are also real numbers. All right, 3 can be stated as 3 over 1. It is a whole number, it is an integer, it is rational, and it is real. -36 equals -6, so it is not a whole number because it's negative, but it is an integer, it is rational, and it is real. All right, so make sure you can do those. You will get problems in the homework with checkboxes, and you'll have to check all that are true. All right, thanks for watching. Sorry, I had more to go. So if you kept it on and didn't turn it off, I forgot I had one more. So this is what your homework looks like. In which sets of numbers would you find the number -833? So you would choose, is it a whole number? No, it is not because it's negative. Is it a natural number? No, that's counting numbers. So these are counting numbers. So it's not a counting number because it's negative. It is rational. It is real. It is an integer. It is not irrational. Right? So it's those three. Okay, now I think I'm done. Thank you for watching.